In this short video, I'm going to introduce you to the concept of the coefficient of determination, which is another way to look at the relationships between variables. So let's get started. When we looked at the age of elementary school students and the percentage of them who were wearing helmets for riding their bikes, we found that as the older students didn't wear their helmets as much as the younger students. And we found a regression or trend line, whereas as the older kids, there were a fewer percentage of them wearing their helmets. So we drew a line through the dots, the data points, and this is called the regression or the trend line. Now, if the dots were all if the data points were all perfectly on that trend line, then there would be a perfect or an inverse relationship there. But they're not quite all on the regression or the trend line. Instead, some of them are above the line and some are below the line. So there's some variability there in where they are. But most of them are pretty close to this regression or trend line in this particular example. And so the correlation is R equals negative 0.92. That's a pretty strong correlation between the age of the kids and the percentage of them who wear helmets. Let me give you another example now. In this plot of whatever it is, if we draw the trend line or the regression line, you can see that the data points are further away from that trend line. There's more variability in this scatter plot, and its correlation is much lower. It's only 0.33. The relationship is not as strong in this particular data set. Now let me go to a concrete example to look at the variability. These are made up numbers, but let's say we took a bunch of fourth graders and we wanted to know how many chapter books they read each month. So this circle represents our sample and the number of chapter books the kids read each month. Now there's a lot of things that could influence or explain why those numbers are so different. Perhaps it's their parent education or the number of books in the home or the kids' motivation levels. There are many, many possibilities for why there is so much variability. And there's a lot of other variables or factors that maybe we can't even label and we don't even know about. But this particular researcher wants to look at the parent education. So she gathered the number of years of education for each of the kids who reported the chapter books they read. So here's their parents' years of education. And when she ran the correlation, she found that it was a positive correlation of 0.63. So that's moderately strong and it's positive. It would mean that as the parents' years of education increased, the kids' chapter books per month, there would be a trend that those would be increasing also. Now, how much, though, of that variability in the chapter books per month could we really account for with the parent years of education? It'd be pretty useful if we could see how powerful that information was. In other words, how much of the variability in the chapter books per month could actually be explained by the parents' years of education. We want to know what that overlap is. And that's where the coefficient of determination comes in. We take the R and we square it. We take the correlation and we square it. And that's called the coefficient of determination. And in this case, If we square 0.63, we end up with 0.40 or 40%. That is interpreted as 40% of the variability in the number of books the kids read per month can be explained by their parents' years of education. So you can see how useful that is and how important it is. So to wrap up, let me give you a couple of examples. There is a correlation between education level and income. I'm going to say that correlation is 0.47. It's positive. So as education level increases, so does income. When I square that and use the coefficient of determination, I get 0.22. That is interpreted as 22% of the variability in income can be explained by education level. Now remember, we're working with correlation, so we don't say that one causes the other. Perhaps we could say that 22% of the variability in education level can be explained by income, but sometimes that simply doesn't make a lot of sense. But let me give you another example. We can measure people's sense of humor. There are several scales and measurements that we can use to do this. And we can measure their positive psychological capacities, such as hope and resilience and optimism and things like that. So researchers have looked at whether there's a correlation between those two constructs. And there is. The correlation is about 0.30. So as sense of humor increases, or the measure of sense of humor increases, so does their positive psychological capacities. That kind of makes sense. It's intuitive, isn't it? When we use the coefficient of determination, we find that it's equal to 0.09. We squared the correlation. And that can be interpreted as 9% of the variability in sense of humor can be accounted for or explained by the positive psychological capacities. It's correlation though. So we can flip that around and it would make just as much sense. We could say that 9% of the variability in psychological capacities can be accounted for by the sense of humor. What we usually do is put the predictor on the x-axis and the y-axis would be the other variable. So you would account for the y variable with the x, and that would be based on your research and what you know about the constructs that you're measuring. So to wrap this up, the coefficient of determination is when you take the correlation and you square it. You take the Pearson R and you square it. And it tells you what portion of the variability in one variable can be explained by the other one. So what portion of y can be explained by x? We usually report it as a percent, and you must be careful which variable is accounting for or explaining the other one. And that should be based on the research that you do before you set up the study.